All right, we are live. I'd like to welcome everyone to the webinar. Happy Thursday. We're here at LPKF Studios in Portland, Oregon, and we're broadcasting across the world today. LPKF's newest webinar, Maximizing R&D Efficiency with In-House PCB Prototyping, Insights for RF and Microwave Executives. My name is Shane, and I'm a Market Development Representative with LPKF, and joining me today is Stefan Schmidt, President of LPKF North America. Thanks for joining us today, Stefan.
I'm glad to be here, Shane. Thanks.
Great. I'll say up front, if you have any questions throughout today's webinar, feel free to submit them via GoTo's question submit form as seen on your screen, or submit them via Twitter. You can do this by tweeting your question with the hashtag LPKF, or you can tweet directly to @LPKF_USA. Go ahead and submit your questions whenever you like, but we are not going to field questions until the end of the presentation. So, to get started this morning, I'd like to open with a recent poll the folks over at Microwave Journal ran. Now, they asked their readers, what's the most important tool in your design arsenal? As you can see, 82% of the over 700 people who responded selected PCB prototype milling machine. Now, we were actually quite astonished with these results internally, weren't we, Stefan?
Yeah, Shane, this poll is actually an amazing confirmation of having in-house prototyping equipment available and how it truly changes the entire design culture, of the engineering world. So, but for the record, we did not sponsor this poll.
We sure didn't. Now, going back to this poll, why is this? What makes a PCB milling machine or in-house prototyping in general such a great fit for those with RF and microwave applications? And just how can you create a more efficient R&D environment by prototyping in-house? Well, there are 4 ways. The first way is by saving time. Now I'm going to throw out a number, 86.5%. That's the number of LPKF users who save 4 days or more per prototyping project. Now that's a lot of time, and it is the biggest factor that separates in-house PCB prototyping from other methods. The second way in-house prototyping creates a better R&D environment is by allowing for innovation. The quick and inexpensive nature of the in-house process frees up designers and engineers to push design limits, which can lead your company to new heights. The third way you can create a more efficient R&D lab with in-house prototyping is by maximizing the quality of the prototypes you make. Milling and laser etching are technologically superior to most outsourced processes, and we'll cover how in just a bit. The fourth way in-house PCB prototyping maximizes efficiency is by saving money. Now this one might surprise some people. Yes, there's always going to be a capital expense inherent with in-house prototyping, but as we'll show, payback value and return on investment for in-house equipment might be higher than you think. But before we jump into those 4 ways, I'd like to run a poll based off of them. What is your main concern when prototyping PCBs? I'm going to go ahead and launch the poll, and we'll keep it open for about a minute.
Now, while Shane launches the poll, I probably have a quick little story that I want to share with the audience here right now. So this reminds me of a situation that happened a few years back. The semiconductor, a customer of LPKF, bought a milling machine to support their custom application team for the sales efforts. But as soon as the test fixture team got wind of it, they immediately saw the value of having a tool to create instant test fixtures, and they literally stole the machine. So the application team had no other choice than to go through the investment process again and get themselves a new machine. But this is probably a good example for some unintended consequences. So once a prototyping machine is there, oftentimes others see the value of this equipment as well. So, but again, this is just a little side story. But Shane, how's the poll doing? You get the poll results back?
Well, looks like about half of everyone has voted, so I'm going to leave it open for just another minute, and then we'll go over the poll results. And it looks like 50% of people selected quick turnaround as the first and most popular answer. The second most popular answer was pushing design limits, which came in at 25%. So 75% of you voted for either a quick turnaround or to push design limits. And it's a good thing because those are actually the first 2 points we're going to cover. So Now that we've gained a little insight into what you're most concerned about, we're going to start here with the first difference that separates in-house prototyping from other methods, which is speed. So I'd like to open up this section with a quote from an in-house user who is Paul Clark at Honeywell Systems. Now he said, "Thanks to our LPKF milling machine, we took a project that should have taken 10 weeks and did it in only 1 week." Now that's a long time. When looking at the differences between in-house and, say, outsourcing, there's a huge gap when it comes to how long it will take to get your board ready to go. Outsourcing can take from days to months depending on the number of revisions you make. And the more complex the design is, the more layers the board has, the longer it will take. Now what you see here is a pretty typical setup for an outsourcing prototyping scenario. Now with an in-house prototyping system, you can go from design to fully testable board in minutes or hours. Now obviously this depends on layers as well, but the time is still greatly reduced. And what you see here is your typical in-house milling machine operation. Sits right on the desk with the computer right next to it, and then you can do everything right from there. So I mentioned in the beginning that 86.5% of LPKF users save 4 days or more per prototyping project. Now if you're wondering where we got this number, a couple months ago we recently ran a poll amongst all our machine owners, and that's where we got it. Now what's even more astonishing, as in the case of someone like Paul Clark at Honeywell, is that 58% of those individuals ended up saving 1 week or more per project. Pretty impressive. So what does all this time saved get you? Surely faster does mean more efficient, but what are the overriding effects on the R&D department? Well, from the same poll, the top 3 returning factors of time saved by prototyping in-house are greater project momentum, increased productivity, and quicker time to market results. So while you always just can't push a button for productivity, keeping employees engaged by providing quick turnaround on their work is the next best thing. To visualize the difference in time we've been talking about, I wanted to present to you a timeline. On the left is what it would take to get a single or double-sided PCB design made if you outsource it. After importing your data and placing an order, and then waiting for the board to arrive, you're looking at 3 days. Not bad, right? Well, with in-house, in the time it takes to prepare an invoice with the board house, you can instead have the board completed and ready to go. That's pretty remarkable. And I would also like to point out that the 3-day estimate with the board house is really a best-case scenario that actually may cost you extra for overnight shipping. And this is in comparison with the 1-hour estimate for in-house, which is actually quite standard and will never cost you any extra. Now, let's say this difference doesn't impress you much. After all, 3 days, 1 hour, still the same work week, right? But what happens when you take that single or double-sided board from the last slide and make it a multi-layer board? Well, with outsourcing, best case, you're getting your board in 6 to 11 days. In-house, you're looking at a day and a half tops.
Now, imagine the difference if you make multiple revisions to the project. In the case of you outsource, you're looking at a month plus. In-house, you're looking at 1 work week. So going back to the quote from Paul at Honeywell, you can now see how easily the 10 weeks versus 1 week scenario can play out. But here's a rhetorical poll for you guys. Who always makes the perfect board the first time, every time?
I sure don't. So, tangibly speaking, all this time saved we're talking about is a huge feature that speaks for itself. But there's something else that this leads to. It's something less quantifiable, but has potentially more value. And that is innovation.
Now, I have a quote here from probably one of the greatest electrical engineers of all time, Nikola Tesla, and that really speaks to what we're talking about here. "I do not think there's any thrill that can go through the human heart like that one felt by the inventor as he sees some creation of the brain unfolding to success." This is pretty deep here right now, but I think it really talks about what we want to address. So sitting around and waiting for the FedEx truck is neither innovative nor productive. But having an in-house milling machine or laser machine creates boards rapidly, and engineers and designers can stay mentally engaged in their work. And this is a huge increase in productivity, as we saw before from the customer surveys. So let's go back to the quote. If an engineer feels that he or she is onto something, big or small, they can explore this with in-house prototyping quickly and easily. And that really spurs innovation and can create designs and can take a company to new heights.
Exactly, Stefan. So 71% of LPKF users report that a more innovative culture results as a benefit of owning in-house prototyping. Now that's a pretty good-sized majority, enough to get some major things passed through Congress, if you will. Now what does this do? What it does is it allows for a trial and error culture. What does this mean? It means that by maximizing efficiency in the R&D lab, you're enabling employees to try new things. It also means that mistakes, even when unsuccessful, don't cost a lot in terms of time or money. Now I say unsuccessful like that because even if something doesn't work right the first time, it doesn't mean nothing was gained. It means you've learned something, whether that is how not to do something or how to get on the right track. In this type of culture, errors are eliminated early in the process rather than late. This has both tactical and economic advantages. I mean, how does avoiding engineering change orders sound to anyone? Huh? And in regards to RF and microwave applications, innovation is at the crux of these designs, more so than in standard electronic designs. So, idle time never leads to productivity, but what it can do is leave projects stalled while your competitors are making progress, and that's always something to keep in mind. Instead of waiting for the FedEx truck, have your employees try out new things, find errors early, and create a more efficient, innovative culture. It doesn't take long for this new mentality to settle in. All it takes is the right tools. And speaking of the right tools, Stefan, you have something to say about this, right?
Yeah, there's actually a little story that I want to share with everybody. So a few years back, a gentleman from Andrews Corporation came up to me at a trade show in Florida, and he asked me what type of product we are offering. So I gave him a quick spiel about in-house prototyping systems and what these systems do. And when I was done, he explained to me that he just hired a very gifted engineer, but one of the conditions in order to come to work for him was that this engineer would have to have access to an LPKF in-house prototyping system, just in order to do his job most efficiently. This was something that I never expected, and I think the story really exemplifies how much in-house prototyping can change the day-to-day culture of an engineer. After a while being used to that type of convenience, next day service is just not good enough anymore.
Precisely. So let's shift now from, we talked about time save, we talked about innovation. Now, let's talk about the next way in-house prototyping enables a better R&D lab. And that's by employing use of better technologies than other prototyping methods. To talk about this, let's just go ahead and walk through the process of creating a PCB. So as you can see, before you have anything else, you must have the design data. To talk a little more about this, I'm going to hand it back over to Stefan.
Yes, Shane, thanks. I want to talk a bit about design packages here. So the choice of the design package is really important, an important consideration in the whole design process and in the flow of the process. So some websites offer free design tools to design circuits, which sounds like a great prize and too good to pass up. So what's really behind this free offer, and why should we consider this? The limitation with these free packages is that they're typically customized in a way that they only export files in one way that is only compatible with the board house. That saves some time and streamlines data and maybe saves some cost with this particular board house. But the flip side is the design can never be transferred to any other vendor. So it's a bit like the coal mine company store. Once you shop there, you can never go anywhere else because they want to make sure you can't take your business anywhere else. Now this can pose a real unintended shortcoming, especially for RF and microwave designers. Now often RF and microwave designs go through many design iterations, and in the process there can be a situation where you really change your substrate as well. Now not every vendor is compatible with every substrate, and if you want to go to a different substrate that your vendor can't do, that may mean that you have to create your circuit board design all from scratch because you don't have access to the design data. So to avoid such pitfalls, we always recommend to use industry standard software design packages that create either Gerber files for the artwork and NC drill files for the drill holes, or DXF files as an alternative. These files are always compatible with every board manufacturer and with all in-house prototyping systems. And therefore, the designer would never get stuck with only one solution and can always make the best choice for the design.
Thanks, Stefan. So once you have the design data ready to go, it's important next that you have the right material for the design. Now, for analog and digital designs, this may not be a huge concern. but if you're working on RF and microwave applications, it is. With materials affecting board performance, there are a lot of factors that must be considered when selecting the right substrate. I mean, you have dielectric constant, loss tangent, bandwidth, thermal conductivity, digital speed. These are just a few of the factors that can ultimately determine which material is right for the design. So with all these factors swirling around, sometimes it takes a process to determine which material is best for the design. You probably know this. And there are some differences between in-house and outsourcing in working through this process. So with in-house prototyping, whether it is more basic FR4 or more delicate RF microwave substrates such as, let's say, RT Duride, TMM, Rogers 4000 series, you can structure it in-house. Now, let's take a hypothetical scenario here. Say you start out with substrate X. After testing your board, you realize that, say, crosstalk interference is high, and therefore substrate X is not going to work for the design. Now, at this point, what's the time to do? It's time to switch to substrate Y, right? Now, with in-house prototyping, you can quickly and inexpensively make material revisions such as this, and then test them out immediately. Now, you just don't have this testing revising ability if you're outsourcing your prototypes. Any performance issues will have to be solved by sending the order out again, spending considerable more time and money than originally intended. And then there's the issue that not every board house can work on every material. You might have to find a specialty shop to fill your needs, which will likely also have a specialty price for the company credit card. And let's just say that you do have to change your material along the way. As Stefan just explained, if you can't transfer your data, then your R&D schedules are going to be way behind, slowing down the whole production process. These are all major factors, especially when you're working with higher performing substrates such as those on RF and microwave designs. So where are we at? We've got our design, we've got our material. It's time next to actually make the board.
So in context of actually etching the design, let's talk about geometric precision and accuracy. With RF and microwave designs, it's more than just sending a current from A to B. It's receivers and transceivers, filters, and all kinds of other features. And the geometric intricacies really matter for the electrical performance. On RF boards, accurate shapes create performance, and little differences can affect the performance quite a bit. So it's important that everything is precise, accurate, and geometrically sound. Now, in-house prototyping systems are working on milling machines or laser systems and have the advantages to technologies that simply outperform etching. Milling machines or laser systems work straight from the CAD files. And as long as these machines are designed properly, the circuit that it produces is extremely accurate.
And to talk a little bit about this, I just wanted to mention that we're not bashing the quality of outsourced boards. They most times will be satisfactory. But in addition to the other benefits in-house prototyping offers, the feature resolution possible with milling machines and laser systems simply goes beyond what is possible via ChemEtch. Circuit features on milling machines can reach tracing space as small as 4 mil, and on laser system, you can even reach 2 mil trace with a 1 mil track space. Now, there are many RF and microwave applications that get this small, and I'll show you one in just a bit. But in addition to etching very fine features, in-house machines reach resolution up to 0.5 microns. So you know you will be shaping your features finely and performance won't be hindered. I mean, this is such a small number, a half of a micron. It's like we're milling in high def. And finally, in-house repeatability is within 1 micron. So you know that you're going to get the same dimensions every time. This is what I like to call production quality. So up here on the screen, we have an application. It's what I mentioned just a second ago. It's an RF application on gold-plated ceramics that was etched on an in-house laser system in literally a matter of minutes. In particular, I wanted to point out the frame on the right. Now that is at a 2 mil trace with a 1 mil space. It's very impressive and certainly has implications for those working with similar designs. Now overall, in-house milling and laser systems outperform chemical etching as a technology. Being able to etch PCBs as accurate and as fine as possible, it makes redesigns less likely, further helping with time and cost issues.
Now, board houses on the other side use a number of sequential processes to create a board. That includes film development, exposure, chem etching, drilling, routing, and so on. So all these steps are performed on different pieces of equipment. Now, it's not that hard to imagine that it's very, very difficult to maintain very tight tolerances with all these sequential processes there. So if you then add RF and microwave substrates, that only compounds the problem, and that's where you see that much fewer of the board houses can deal with this type of option too.
Exactly. So after the board has actually been made, what's next? It's time to populate it. After that, it comes board components that need attention of their own. So Gary Ingram, who's an engineer with Raytheon, says it better than I could. He said, with any new components, you have to see how they perform in the environment in which they will be used. LPKF equipment allows us to make test PCBs for evaluating the performance of new RF and microwave components. So being able to test components is huge. With an in-house PCB prototyping system, you can produce test circuits that measure component performance to make sure they work independently of the whole board. Now, Stefan, you had something else to say about this.
Yeah, so I mean, the components that you use, I mean, there's such a wide variety of components. There's transistors, ICs, filters, mixers, attenuators, and all that sort of stuff. So, imagine how difficult it is if you pick the wrong component for your board and then you don't get the right performance. You would have to go all the way back and qualify a new piece of new component and then start over again. This can get real spendy real quick, and it's often the reason why people switch to in-house prototyping. So maybe you remember the little story that I shared with you during the poll with the semiconductor company that started using this equipment for test fixtures. So creating a number of test fixtures instantly to qualify components at a minute's notice is really not very feasible with an outside vendor, but it's a really attractive option for when you have an in-house prototyping system.
I mean, I agree. So whether you test your board populated or unpopulated, the final step in the process is the testing and revision phase. And this is where the benefits of in-house prototyping we've talked about in terms of speed and cost really show. So the ability to test boards on the fly is crucial to the design process, especially for performance-centric boards such as RF and microwave designs. Now with outsourcing, as I mentioned in the materials section, the board you order is what you get. If you need to revise the design, you're going to have to spend additional and unnecessary time and money to do so. With in-house, you can find errors early and make revisions extremely efficiently. This is huge with designs that are going to need a little extra attention or tweaking, such as many RF and microwave designs. Now, for any company, the bottom line is crucial, and as we've seen, the scant cost for materials to test boards and make revisions in-house is minute when compared with the cost to send successive iterations to an outside provider. Bottom line, testing during development helps with the unforeseen. Errors will always arise with boards, no matter which option you choose for prototyping. The difference is that you can accommodate for these errors much quicker and much less inexpensively in-house. So we've covered a lot of the benefits in-house prototyping has on the R&D process. Now, maybe you think this is a trade-off and that all these benefits are going to cost you a pretty penny. Well, you'd be surprised. To reflect this, I'd like to bring up another quote from an in-house user. This time it's Robert Kobach from Shure Audio. Now he says that the cost of a 4-layer 150 board run may be $10,000, while the cost of the LPKF milling machine Shure purchased was under $30,000, including accessories and consumables. So if you want to talk about financial inflow exceeding financial outflow, you have it here. Under a scenario such as this, in 3 board runs you will reach payback on your machine, and in 3 more you'd be near 100% ROI. After that, it's nearly $10,000 in your pocket every board run. Now, I understand this is a pretty extreme example, and not everyone is going to have a scenario such as this. So let's take a look at a more median example. So the cost of an in-house prototyping machine may seem like a lot, but as this chart shows, even average prototyping volume can justify payback. What's here is a sample financial scenario involving ballpark numbers to move outsourced prototyping in-house. Again, very median financial scenario, ballpark numbers. So the $15,000 figure you see highlighted, it represents the cost to produce 100 double-sided boards at average board house prices. Now this $15,000 workload would take, and this is a high estimate, $4,000 for the materials and tooling necessary to complete the workload in-house. Now this is a savings of $11,000 a year. Now with a machine that costs, say, $25,000, this gives you a payback of 27 months and annual ROI of 23%. Now these are great financial numbers and something to think about. I'd also like to point out that in our calculations, we didn't factor any rush fees you would have to pay to get your boards expedited or overnight if needed.
And I think it's important to point out here that the $4,000 estimate for in-house prototyping cost is a pretty high estimate, and in many cases it's less. This cost is depending on the type of board substrate, the tools that are used, and the options that are chosen, such as legend printing or silk screening, which not every user uses for every prototype all the time.
Exactly. But let's talk about what makes a PCB prototype cost what it does. Well, in outsourcing, there are going to be premiums on board design. The more complex the design, the more layers the board has, the better the materials you use, the more prices will increase. And of course, if you don't want the standard shipping time, it's going to cost you. Over the course of a year, companies with even an average throughput end up spending quite a bit on outsourced prototyping, more than they really need to, such as the $15,000 we saw on the last slide. In-house, you have the initial capital expense of the machine, which can be a considerable factor. However, while the price tag may seem like a lot, as we just saw, you'll end up saving money in the long run because the material and tooling cost to make a prototype in-house is far less than what you would spend on the same board if you purchased it from a board house. We'll go ahead and take a look at that here. So I have a chart, and what it does is we're going to visualize the material cost to make a board in-house versus outsource. So as you can see, as you go from single double layer to multi-layer, in-house you're adding small material increases to your cost. But do this at a board house, and you can see how the curve spikes. Many people know about the time-saving benefits of going in-house, but many don't realize that most setups will see value gained by switching prototyping to in-house from outsource. Now, if you would like more information on this topic, quick plug here, we'll be having a webinar soon which explores how to provide financial justification for a machine. It's called How to Write a Business Case for Engineers, and this is going to take place October 25th. If you'd like to register, I'm going to put the link in the chat room at the end, and we'll also include a link in the follow-up email to this webinar.
So what do all the factors that we have covered lead to? What happens when you're saving time, when you're innovating, when you're implementing better technological process, and you're saving money? You'll get the full-scale R&D development. All cogs are working together. Outsize is the best option when it comes to production of larger quantities. The board house industry is very well versed for this task. But when it comes to the R&D phase, where momentum, innovation, and efficiency are the utmost importance, the best option for prototyping is typically in-house.
Thanks, Stefan. So with that, this very quick last 30 minutes, we've reached the finish line. Not too bad, huh? So as I said, if any of you are concerned about a recording of the presentation, I will be sending that and a copy of the slides to you either later today or tomorrow. But for now, I just want to take a moment to thank everyone for dropping by. And I'm not just saying that. It means a lot to me personally because I don't want to be talking to no one. And on behalf of LPKF, we really value your interest in in-house prototyping. Now, we'll be answering questions in just a moment. So if you have any, feel free to submit them via the questions window in your panel or on Twitter, #LPKF or @LPKF_USA. If you'd like more info on in-house PCB prototyping, feel free to contact us by any of the above methods. But I must say, if you want a more immediate response, I'd recommend calling or emailing. So with that, I'm going to hand out the link for the white paper accompanying this webinar. I'm going to put it down in the chat room, and then I'm also going to put down the link for the upcoming webinar to follow this up. But right now, if you have any questions, go ahead and get them in, and then we'll field them in just a moment. All right, so we're going to go ahead and jump into questions. First question is from Michael. Now, Stefan, he says, given the existing laser versus milling technology, can you give the price-conscious customer an idea of the cost to purchase each system?
No, I think that's a very good question there because, again, of course, there's quite a difference in the technology, although we are still making prototype boards on both machines. Now, prototyping machines, mechanical prototyping machines or milling machines, are typically starting in the area of just about $8,000, just to give you a ballpark. Those are fairly simple machines that are mostly used in an educational environment. Most industrial customers probably looking at machines in the $20,000 range, and with all bells and whistles, these things can go up to $25,000, $26,000. So this is for the mechanical side. If we're looking at the laser end, we are looking at a price tag of something like $120,000. So it's quite significant, the difference in there. But again, the laser systems have a very different ability in terms of smaller resolution and much smaller features, and they're also a lot faster. So a lot of customers choose those systems to actually produce something what we call production on demand. It's more a coin that we termed a term that we coined because we didn't have another term for this. It's really cranking out a lot of different boards really quickly without having to go through an outside vendor.
Oh, thanks, Stefan. So next question is from Stephanie, and she says, what is the smallest trace width pitch an LPKF machine can produce?
That depends typically on the type of substrate that's chosen. We specify the machines as the smallest trace and space width to be 4 mil trace and 4 mil spacing in between. Now, of course, you can push that envelope a little bit. You can probably bring it down to slightly smaller traces, maybe 3 mil, but that often depends on how good the adhesion of the copper foil on the substrate is, and that varies, especially in microwave boards. If you're talking about a very soft a Teflon substrate, you probably don't want to push the envelope too hard and bring it down to the 4 mil area. So probably 5-6 mil is probably what you see in most applications. Now, if you have a little bit of material with better bonding strength, let's say the TMM materials or the Rogers 4000 series, you can push the envelope quite a bit because, again, your copper foil holds on much better to the substrate there. Again, that's the side on the mechanical milling machines. If we're talking about the laser systems, same thing here. The trace and space width is not really a function of the machine. It's much more a function of how good is the substrate itself. Now, we can produce easily 2 mil traces and spaces with most common substrates. But if we're going to ceramic substrates or alumina, for example, we can push it down to 2 mil traces and 1 mil spacing in between.
Awesome. Stefan, I learned so much from you. All right. So Marwan wants to ask, he says, what is the approximate cost of a quote-unquote starter machine that can do a 3 or 4 layer board? And he says 2 grounds with no components, 2 circuits facing outwards.
So, the most common type systems that we see, in this middle of the range is probably, you're looking at something like $20,000. These types of machines have, automatic tool changes, and they have automatic fiducial recognition, which we use for registration of multiple layers. So to make the process fairly easy. So if you budget for something like $20,000, you're probably in a pretty good neighborhood for that.
Great. And we have one final question from Dave, who says, I think what he's getting at is if say a customer is looking at one of our machines, but they're just curious if we can do the design. Now, will we work with them to provide samples of their design?
Yeah, we are more than happy to. So if you're interested in seeing what an equipment like this can do, then please contact us or our sales team, and we're more than happy to produce a custom sample for you, and we can show you what in-house prototyping could do for you. And trust me, once you see this, you don't want to go back to Boardhouse anymore because, again, you can't live with next day service anymore once you have that.
Exactly. Let's hold on and see if there's any more questions. All right, looks like we have one final question before we head out. Michael asks, does LPKF offer any technical support with regard to process support, milling and assembly, soldering, etc.? Stefan?
Yeah, actually we do. LPKF, we offer the entire equipment line. So we talked a lot about milling machines and laser systems here, but we have all the other equipment in terms of assembly, PCB SMT pick and place equipment. We have reflow ovens, so we can really help you with all your in-house prototyping needs, and really can help you with setting up and organizing your entire prototyping process. And that goes beyond making the board itself. That includes the assembly and the soldering of the board as well.
Okay, and I think that's it. So. Like I said, we'll hand out a copy of the slides, recording of the presentation soon. Once again, I want to thank everyone for attending, and go ahead and have a good weekend. Thanks.